for vectors at any angle, instead of being on a bus, let's imagine we're on a sailing ship and we sail down here to vector A, and then we make a turn and we tack back along vector B. And we need to find, once again, our displacement vector R. So once again, same way we did last time, we go from our first tail to the last head, and we draw our vector R. Now to solve that graphically again, you would get out your ruler and your pencil and your paper, and you would draw your line A to a scale, and then you would draw your line B to a scale. And of course when you're doing that, you would have to know the angle alpha. Once you've got the angle alpha, you can draw that using your protractor. And once again, when you define the angle of the vector, you need to define it to the x-axis. And so then you would have R, your size, and the angle. And if we looked again at adding multiple vectors together, if your boat was sailing a crazy path like this, tacking backwards and forwards at the wind, your final displacement vector would go from the first tail to the last head, like that. And again, you would measure the size with your ruler, and you would define the angle with respect to the x-axis. So solving these problems graphically is just like solving the simpler bus problem graphically, except that in each of these you would need to be given these angles, because you're not just moving at 90 degrees anymore. So now that we've looked at solving vectors graphically, we need to learn how to solve vector additions geometrically, and that means with triangles, using simple trigonometry. Let's define our vectors. We'll have a vector A, which has a magnitude of 3.5 and an angle of 160 degrees to the x-axis. And we'll define our vector B, which has a magnitude of 6.2, and we'll give our vector B an angle of 35 degrees to the x-axis. So how would these look if we were to define them graphically? Well, let's get our x-axis, and we'll start with our vector A. Start here, and we need an angle of 160 degrees. So that means we need to go all the way over here for this, and that would be our angle. So this here would be 160, this here would be 20. So we draw in our vector A. Whoop, that'll do. We draw in our vector A, pointing this way. And then we have our vector B. Once again, we need to add them head to tail. So we know our vector B is going to start from here and go roughly in this direction. So if I draw another x-axis here, our angle for vector B is 35 degrees, and that means it looks about like that. So we would draw our vector B in here at 35 degrees with a magnitude of 6.2, and A, as we said, is 3.5. Then we need to find our resultant, which goes from the first tail to the last head. Now, in the past, we solved that graphically, and now we're going to learn how to solve that geometrically using trigonometry. And to add these vectors using trigonometry, we need to get this a bit clearer and draw it as a triangle. So we've got our first side here, which is 3.5. That's our side A. We have our second side here, which is B, and that's 8.5. And we have our third side, which is actually our resultant, and we'll call that C, and that is what we have to find. Let's draw an x-axis in here. It's give us our angles. And we'll draw in our angles. Opposite A, we have the angle alpha. Opposite B, we have the angle beta. And opposite C, we'll have the angle gamma. So now we're ready to treat this as a problem in trigonometry. Now if we go back to our definitions here, we can find the angle gamma by looking at here. We draw some extra lines here. We know that this here is 20 degrees. That's our angle, or our opposite angle for A. And that means the angle here must also be 20 degrees. Let's draw that a bit clearer. We have a line here. We have a line here, two parallel lines. We draw a line through them there. So we know that this angle must be equal to this angle. And that tells us that this enclosed angle here between A and B must be 35 degrees, the angle of B, plus 20 degrees, the opposite angle of A. And that means that the angle gamma is equal to 55 degrees. So now we have one side here and one side here that we know, and we have an angle between them. And that tells us straight away that we can use the cosine rule to find the other side. So let's write our cosine rule up here. And that tells us c squared is equal to a squared plus b squared minus 2ab cosine gamma, the cosine of the angle between the two sides. Now this is all basic trigonometry, so I won't go through all the steps of this, but what you end up with is that c squared is approximately 50.87, and that tells us that c is about 7.13. So now we have our magnitude of c. So now we need to find our angle here of our displacement vector. We have the angle on this side. We know that that's 20 degrees. So next we need to find the angle beta, and we do that using the sine rule. So we use the cosine rule to find our missing side, and now we use the sine rule to find our missing angle. And the sine rule tells us that b over the sine of beta must be equal to c, which we've just found, over the sine of gamma. And that means that the sine of beta is equal to b times the sine of gamma over c. And if you do the maths, that tells you that that is 0.976. And when you run that through your calculator, that tells you that beta is equal to 77.47 degrees. So this angle here, the one that we're looking for, that must be 180 degrees minus 20 plus 77, and we'll call it 77.5. That means that that angle there is approximately 82.5 degrees. So now we know that our resultant has a magnitude of 7.13. That's our magnitude. And it has an angle of about 82.5 degrees. So we've solved this problem geometrically instead of graphically. And the great thing about this, despite the fact that it looks very messy, it is a wonderful technique because it allows us to do very complicated vectors, and it allows us to get the precision as accurate as we want it to be. If you're just using a ruler and a protractor, it can be very difficult to get a really precise answer here. But using your calculator and some simple trigonometry, you can get a very precise answer that tells you exactly what you need to know.